So what I have discovered here, fire damage doesn't do no damage to Magmarock, it actually heals Magmarock. It's too bad that these values are both unsigned integers. Except, if we look closely, there's one value related to his health that isn't an unsigned integer. So my plan is simple. I'm going to heal Magmarock to death. And here we are once again. I tell you, back in Ghidra far too soon, as far as I'm concerned, but it's a necessary step. So what I have discovered here, this is just through basic searching, function under M is Magmarock. And within these code segments are some very interesting potential solutions here. We also have damage here. Alright, so if we follow some of the logic here and keep in mind that this is decompiled pseudocode, so the indenting and declarations and stuff, it's going to be a little weird. That's just a normal part of this process. But we can see up here at the top, one of the parameters that's passed to Magmarock damage is param4, which is a damage type. And our first evaluation is if that is a fire damage type. After that, what seems to happen in that if statement is some variable reassignments, and eventually param3, which is an int, is multiplied by 4. And then we have an else if statement that says here that if param4, so the damage type, is not cold damage, then param3 equals param3 divided by 2. So essentially what this means is that any damage type other than fire damage and cold damage is going to be halved, right? So param3 is clearly, I'm going to rename this now. I'm just going to just name it damage. Param4, I'm going to rename this to type. Okay, so if type equals fire damage, and then else if type does not equal cold damage, then damage equals damage divided by 2. So cold damage is mentioned again down here. But what does fire damage do then? If fire damage does something other than half damage, is it no damage? I mean, Magmarock is apparently a fire type of creature, right? So does it do no damage? No. There's definitely more code here than just zeroing out the amount of damage. I mean, if that's all we had to do, then it would be, param3, or in this case now int damage equals 0. Right? It would be as simple as that. But that's not what's happening here. So let's follow this around here. So we know that the 10,000 here is mentioned twice in the assignment of dvar3, and it's also mentioned again in the assignment of uvar1. And then it's part of, somehow, an assignment of uvar2, which does some kind of arithmetic with the damage, a multiplication with the damage variable, which also includes somehow that 10,000 figure from dvar3, right? So let's just, for now, keep these values in mind. This 10,000 figure, this times 4 damage, and let's continue the process of reverse engineering and see if we can figure anything else out. So after those, we have a new code segment, another if statement here. This M healing active does not equal false. So true. All right, so when healing is active, if 0 is greater than damage, so if we're doing damage, then damage equals damage by half. Okay, so essentially it's another check that when healing is active, we're automatically going to be doing half damage while the healing process is going on. For some reason, this is another artifact of the decompiler. We have another if statement with the same condition that jumps us to the same label. This is clearly some kind of an error. So what's at that label? It's right down here. That label is enemy damage. So this is not a Magmarock damage. This is just a general damage enemy function. So basically, this function here has the code that is particular just to Magmarock, and once it's processed, it passes all those parameters back onto a general or generic enemy damage function. So maybe there's another potential avenue here, for some kind of malfeasance as well. Like, what if I can change this condition so that anything other than cold damage, instead of doing half damage, what if I manage to change that so that instead it's twice as much damage, 4 times as much damage? Something like that would probably work for an offline version of the game. But my guess is, based on everything we've seen so far, that there's some kind of server-side validation here for the health or something like that. We could certainly give it a shot and see what happens. Let's check out some of these other functions. Get attack time, get death message, get display name, return Magmarock. Okay. Get max health. Okay. Well, this confirms it. Magmarock's max health is that 10,000 figure. So now we know a little bit more significantly what these figures are. All right, so I've renamed these different local variables here. And let's step through them so we can kind of see what's happening. So this is Magmarock. We can see up here at the top, our first argument is Magmarock. So that instantiation of the Magmarock object equals this. Field is going to indicate essentially a memory address or variable. In this case, the variable that's going to be at hex offset 30 of the Magmarock object in the game. So when it instantiates wherever the Magmarock object exists at offset 30, there's going to be a variable of some kind. In this case, because we're talking about damage here, Magmarock's health makes perfect sense. This is very similar to our own player object. We've already examined that, and we know that at various different predictable hex offsets from the top of the player object, we can find things like our mana and our health and our X, Y, and Z value and our run speed and all of these other cool things that we've been doing so far for lead hacks. But what is this line doing then? If it's taking the health variable and dividing by 10,000, well, we know from the get max health function that 10,000 is Magmarock's maximum health. And what do you get when you divide a current value by the maximum value? A percentage. So what was dvar 3 in this case, I have renamed to percent damage because that's what it is. It's a variable that calcs what percentage of Magmarock's health is currently available. And this is in the damage function, which means that every time Magmarock is damaged, it calculates his current percentage of health. Again, keep in mind that this if statement is just an approximation by the decompiler. We have to take everything we see here with a grain of salt. So while it certainly could be only if Magmarock is damaged by fire that it would update this variable, could be, but we've been in the game and we've already gotten him down to half health and started his healing animation, so we know that that's not likely the case, because I never used fire damage in that fight and he still was new to heal when he got to 50% or so. What was UVAR 1, right here I have renamed to raw damage. So what this does is essentially calculates Magmarock's current health, because that's what's at this field hex offset 30. We know that from the first variable we just looked at. It calculates his current health. It essentially takes the max health minus whatever the current value is, right? So let's say, again, he has 8,000 health left. So this is just 10,000 minus 8,000. And that variable tells us that his current health, or the difference in his health, I guess I should say, is 2,000 points. It puts that into an unsigned integer, as is the variable I've renamed to neg damage. So what neg damage does is it multiplies the percent damage and the damage we are doing, so the percent damage and the damage we're doing, and multiplies that by 4 and assigns it into the neg damage variable. So let's walk through that. So our percent damage, let's say, is 0.8. The damage that we are doing is, so this will be times, let's say we do 20 damage, I guess. And then we will multiply that by 4. So we would get a value of 64. So neg damage now equals 64. And then it assigns that to our damage variable and inverts it. So 64 would become negative 64. And then what happens to damage? We have to go all the way down here, and it's eventually dumped into the enemy damage function that actually would then pass on and do the negative to the health, the same thing that all other creatures do. The Magmarock damage function is only going to contain code that is specific to Magmarock, right? The rest of the code that's involved with damage, like the calculating the health bar and all of that's for any creature. We don't need to rewrite that just for Magmarock, right? But what is negative damage, right? If it's inverted, negative damage is healing, right? So fire damage doesn't do no damage to Magmarock. It actually heals Magmarock. And this is really important later because Magmarock's got himself a special ability. But we'll get to that in just a moment. Let's see what else we got here in the Magmarock class. Get ranged attack distance, which is another fixed variable. Is elite true on killed, on prepare attack. Here's a should attack. Here's the Magmarock function. So the Magmarock class, Magmarock function. There's his name. Okay, here's his health. So this is where this field, hex 30, is assigned the value for his health. Okay. Quest timer, 5.0. Oh, here we go. This is where M healing active is originally set to be false. So this isn't going to help us with disabling it, but it is good to know that it is simply a Boolean, and there's got to be code somewhere that detects a condition and flips that to true, and that's the one we really want to get at. What is this? Oh, that's the stack cookie. Now, this is also something that's really important that maybe you're not aware of, but the values here, both raw damage and negative damage, they are uints, or unsigned integers. This is significant because of this. So maybe you've seen this before. If not, let me explain. So in this case, Genie, of course, always grants 3 wishes, right? That's the magic number for genies. Everybody knows that. If you use your first wish to make the number of wishes you have 0, then the genie will do so and deduct 1 wish. But for a genie, what is -1 wishes? Well, they don't have any. Genies can't give you negative wishes. So that means that the viable range, the number of wishes we can have, has to be a positive value, a positive integer. So what is the highest number that we can represent with a single byte? So if we have half a byte, 1111, and the other half of the byte, 1111, then the highest number that we can represent with a single byte is anywhere between 0 and 255. So we are granted 3 wishes, which in binary is represented by 0011. We ask the genie to set it to 0 wishes. So now what happens if we -1 wishes? Well, look at that. What a strange thing to have happen. We seem to have caused some kind of an error. So if, I'm going to go up to hex here. So if I were the genie, and I'm now at -1 wishes, and I look in my byte buffer to see how many wishes are left, what do I see when I look at that byte? I see 255 wishes. Anyway, this goes into a number of different areas, but suffice to say that that's the maximum value that we can possibly express here for our genie. Anyway, how does this relate to Magmarock? So what's important to note here is that both raw damage and negative damage are declared as unsigned integers. So what is the difference between a signed and an unsigned integer? So as we see here, a signed integer is a 32-bit datum that encodes an integer in the value range negative 2,147,483,648 to a max range of positive 2,147,483,647. While an unsigned integer is a 32-bit datum that encodes a non-negative number only in the range of 0 to 4,294,967,295. So essentially, an unsigned integer can only be a positive value. And when we exceed the bounds of either the upper or lower limit, it will simply wrap around, sort of like the odometer in a car. When we overflow one of those in C, C++, C#, so on, essentially Magmarock's health, if we heal him sufficiently, could take us from 4 billion something. We could, theoretically, his health could be up to 4 billion. And if we manage to heal him past that value, well, sure, it becomes 1, and then he'll heal himself, and that's not really gonna help us. But a signed integer, that is a range that has a lower upper limit of about half of an unsigned integer, but the other half of that 32-bit datum represents negative numbers. It's too bad that these values are both unsigned integers. Except, if we look closely, there's one value related to his health that isn't an unsigned integer. We see it several times where this field, hex 30, is referenced. It's called as an integer, not an unsigned integer. Which means that while all of the calculations in this function are being done on unsigned integers, the actual value on the Magmarock object is actually a signed integer, meaning that if we can get his health up to and beyond 2 billion, it will wrap all the way around into negative numbers, killing Magmarock instantly. Okay, we are almost ready for what we hope will be our final confrontation with Magmarock. After spending some time digging around in the code, I came to the conclusion that there likely is another solution to Magmarock somehow, but that I currently am unable to figure out what that is. And so, like the Unbearable Revenge quest, I'm going to do it and get it done with the way that that I know it can be done. I kind of want to test to see if the water is just a solid surface, so maybe the lava is just a solid surface too. I walked all this way. I don't want to have to walk again if something happens. Anyway, so like the Unbearable Revenge quest, I'm going to go ahead and do it the way that I know the solution is most likely intended to be done. And if I come up with another solution later on, I'll just film that too. So what we're going to do is we're going to take advantage of what I was talking about before, the fact that that signed variable has an upper limit, and when we breach that upper limit, it wraps around into negative values. Let me get a diagram here so I can show you kind of what we're talking about here. All right, so a couple of things that we need to know. So from reverse engineering here in the Magmarock class, we found a couple of really important variables, some really important information. So we know that the Magmarock character has a maximum of 10,000 hit points. That's his normal standard hit points. We know that when he reaches 5,000 or less than 5,000, that it begins a healing animation. That healing animation will take 5 seconds. And at the end of that animation, he will heal this amount. So this Field hex 30 is the current health, his current active health. And there's an addition function here for how much? In decimal, 4,975. So let's do some quick maths. All right, so we know that when Magmarock is in his normal condition, he has 10,000 hit points. And his normal gameplay loop is that he will be in a, let's call this an attack state. So he's in his attack state when his health is at 10,000 until, so this will be between 10,000 and 5,001. All right, so when his HP is at that level, he's in his attack phase. He's standing there, targeting us, firing fireballs. When his health reaches less than or equal to 5,000, or half his total health, then he goes into a healing phase. When he heals for 4,975 hit points, meaning that if he's at exactly 5,000 hit points when he begins this animation, means after he's done healing, his new hit point total will be 9,975 hit points. If he's slightly lower than that, then he'll be at less than 4,975 hit points. The problem is that unless we can basically take him out in less than 5 seconds, then he's going to continually heal, because every tick he's making this check. This is the gameplay loop, right? The gameplay loop is attack phase to healing phase to attack phase to healing phase to attack phase, over and over again until the end of time. But if we can get Magmarock to have, let's say, -1 HP, or even just 0, I think is where the check is. So let's actually say this. Let's say instead of doing less than, let's do less than or equal to 0 HP is our win condition. That's where Magmarock dies. And that's what we want. Since it's going to be very, very difficult for us to get him below 0 by subtracting his hit points with attacks, there's another method that we're going to use, which is we're going to overflow that integer, that signed integer. That is his, not his total health, but his current health. So if we can overflow a signed integer, what's to stop us from taking our fancy new fireball spell and just, while Magmarock is here at full health, just kind of blasting him? And, why do we have to damage him at all? Well, it's because there is a bounds check that occurs for his hit points. If his hit points are less than 10,000, it's checking to make sure it doesn't go over 10,000. Okay, so if we want to monitor the current value here of Magmarock's health, all right, we need to run a scan for it, right? So he's currently a bit damaged. So what I'm going to do is I'm going to continue to damage him until he basically heals back up to full, and then I'm going to search for his health value in Cheat Engine. There we go. So it's one of these two values. I have searched for these before, but I have not actually, I didn't actually save them or anything. I didn't do any pointer scans. But that's fine. That'll get us what we want. So I'm going to move this over here. And let's try a little bit of healing, and that'll verify for us that we have the right place. Yeah, see, those values are going up as I hit Magmarock with the fire spells, which we know will heal him. So let's keep healing him. Let's see if we can get him over 10,000 just by healing him in this fashion. Okay, he's at 10,000. But he can't go over 10,000, apparently. So we can't get him over 10,000 in this fashion, right? Because there is a bounds check. All right, so then what the plan is to, number one, get his hit points less than or equal to 5,000. Then he'll begin his healing animation, which means that we'll have 5 seconds to heal him. So we'll have to switch to our fire spell and heal him up. What we need to do is heal him up to a point where when he adds 4,975 hit points to his total, it actually takes him past 10,000. So we'll need to heal him up the difference between, so 5,000, so at least 25 hit points. We need to heal him up greater than or equal to 25 hit points. And that's assuming that we get him right exactly to 5,000. All right. And if we do that, then his current HP would be greater than 10,000. And then we can just keep healing him and healing him and healing him until we get past 2 billion. And then the value will flip to negative and he'll die. So keep your eyes on these two values here, these two memory addresses. That represents Magmarock's health. And let's do this process. Actually, let me also put the regular fireball spell back in my bar because it uses much less mana, like less than half as much mana. And I'm getting the sense that the Char Star is great. It's doing a lot more damage, but it's also using up my mana pretty badly. So we're going to have to kind of time this so that when we get close to 5,000, we let our mana regenerate. Okay? So let's do our damage. Flappy Bird, Flappy Bird, Flappy Bird, Flappy Bird, Flappy Bird, Flappy Bird. All right, we're getting close. Let the mana regenerate. We're at 6,416 hit points. Mana regeneration takes a very long time. Let's see, one hit seems to be doing, what are we at here? 5,776, and then one more is, so a little more than like 109 or so. So I can hit him with a couple more. Maybe one more. You have to be careful because if your projectile collides with his, then they explode. No, no, spider. You you killed your buddy. Okay. All right, I'm back up to full mana. It's going to take like maybe 1 or 2 more hits. Oh, yes, we are right on the line. 5,008 hit points. So 8 hit points away from triggering that animation. All right, so we're going to hit him with one more ice. All right, we could actually hit him with a bullet because we know that damage is halved. So we could really creep up on the 5,000 mark here. Let's see if we can do that. All right, I'm going to hit him with the Cowboy Coder one time. It might take him past 5,000 or at 5,000 or not. It did. Okay, switch the fireball spell. Heal, 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 heal. Gotta get him up. Oh, yes, we did it. We did it. So, see right there, those memory addresses, we are above 10,000. So we managed to heal an excess amount to get us past that value. And now he has more than 10,000 hit points. And that's exactly what we want. We wanted him to somehow have more than 10,000. Now, we're just going to keep healing him until he dies. Come, Magmarock. Become extra healthy. Become extra healthy. Oh man, this fireball spell is doing a lot more, well, in this case healing, but a lot more damage. But yeah, it is brutal on the mana. It doesn't help that his goddamn projectiles keep getting in the way. Alright, I think I'm going to switch to the regular fireball spell because this is just using up so much mana. I feel, but the DPS is higher. Way higher. I guess DPS doesn't include when you run out of ammunition or whatever. Yeah, it feels better because when I run out of mana, I only have to wait for 4 mana to regenerate before I can cast it again, rather than waiting until I regenerate 9, so it's 4 seconds versus 9 seconds. I'm going to go with this. The Char Star is probably better when you're at full mana, and the regular Fireball is probably better when you're out of mana. There he goes! Timber. Magmarock. You didn't stand a chance. You're a worthy warrior, but you didn't count on my secret weapon. Killing with kindness. Loot the chest. Flag of the Lava, the Golden Master, Pwn coins. Got it all. The Golden Master here is a revolver. It's an improved cowboy coder, it seems. Let's kill a spider with it. Yeah, the golden gun. Let's kill a spider with it. Come here, spider. Kills spiders dead. Kills hearing faster. Oh my god, it's so loud. It's almost as bad as the sniper rifle. What the hell? Give a fella some warning. Tinnitus. The real killer. We did it! Magmarock is dead. What are we on to now? Well, as it turns out, we are very close to the end here. There's only 2 more flags to collect. One of them is the Overachiever flag. The other one is Blocky's Revenge. Blocky's Revenge is no joke. It's pretty major, all right? So essentially, it's probably going to take a couple of videos to hammer it out and to explain what's going on. And I suppose I'll speak more on it when we actually get there. All right, take care. Have yourselves a good weekend, and we'll see you next week.